Hello all, Paul on the plane here. Today's video will serve as the launching point for the Paul on the Plane Archer Sage Image Analysis series, and we'll cover the tools we use to perform the forensic examinations of the images we receive from the space agencies. The premise of the series of videos we plan to produce is to empower all who wish to start doing their own forensics on the photos, the information needed to start their own image analyses as well. We're extremely excited to bring this to you and hope you find it insightful and valuable. First things first though, our disclaimer. These videos are not flat earth proof. I repeat, not flat earth proof. The series is being designed, produced, and will be published with the intent of exposing NASA and the other space agencies' fraudulent activities and false claims. You can draw your own conclusions from there as to the why, if you like. So without further ado, let's walk through the handful of tools we, Archer Sage and I, are using. They are all free to download and use, and the links are in the description of this video. We'd encourage you all to download and use them. Like us, you'll start seeing inconsistencies, anomalies, and strong evidence of image manipulation. So, happy hunting. Okay, the first tool I'm going to mention is called Photoscape, a free and easy to use photo editing software program. I only bring this up in case you don't already have a photo editor and need one to use. What I really like about Photoscape is the ability to simply drag and drop photos right into the UI and start editing quickly and easily. I've just dropped a few photos in here from some pictures I took with my Nikon P900 of the moon earlier this year. From there, you can easily use the tools to adjust the levels and start looking for evidence of image manipulation. Okay, second, there's a program called JPEG Snoop. Again, this is a free and easy tool to use to analyze JPEGs, and there's a few other file formats. Please see the link in the description on the other formats the program can use. But JPEGs are the main ones we'll be using this tool to analyze. So what is JPEG Snoop? Well, what it does is it compares an image against a large number of compression signatures and reports what digital camera and or digital software that was likely used to generate the image. This is extremely important information to determine if a photo has been edited or tampered with in any way. If the compression signature matches Photoshop, for example, then you can be pretty sure that the photo is not an original. JPEG Snoop also provides other useful information such as chrominance, luminance, chroma subsampling, estimates JPEG quality settings, resolution settings, and EXIF, I call it EXIF, I'm not sure if that's how it's even said, EXIF, metadata, which is the embedded information in the image file that was from the original point of capture. You can see here real briefly the first image I brought in was a raw image from my camera again, and the overall assessment from JPEG Snoop was that the file was most likely not manipulated or edited in any way. It was appeared to be unmanipulated. However, the second photo I brought in was one that I got offline, and as you can see, the analysis tool shows that it had been edited. It had been there was some post-production work after the image was taken, and that's the kind of thing we're looking for. Okay, on to the third and final tool we'll cover today. This one actually doesn't require a download to your hard drive to run. It's simply a website you point your web browser to. You pull in your image, all customary formats are available, and start using the various tools that it has. The program is called Forensically, and the link is in the description. You can go there right now, pull in an image from your computer, and start playing around with the tools. Now the help link here on Forensically is extremely valuable, and I'd start there if I were you, and read the blog post and watch the short video that the programmer put together upon its first release. He's added a few more tools since, but the video gives you a good basic rundown, and the blog provides even more information. So the tools we can use here for our image analyses are pretty extensive in Forensically. We're just getting to know them ourselves. Besides a great magnifier, the first tool I'll point out is the clone detection tool, that once you learn how to adjust the parameters, you can hone in on the parts of the image that indicate there's some copy and paste going on, or the clone tool has been used. Then there's the error level analysis, which compares the original with the compressed version, which can make any manipulated parts of the photo stand out. Okay, onto the noise analysis and level sweep tools. These exist so you can remove the rest of the image and leave the noise, which may point out things like airbrushing, deformation, warping, etc. Level sweep gives you the ability to quickly and easily sweep through the histogram and potentially make edges that were introduced because of copy and pasting visible to you as the analyzer. Next, there's the luminance gradient, which is one of the coolest features. This analyzes changes in the brightness along the X and Y axes of the image and compares them in order to find anomalies in regard to how the object in the image reacts to one or more sources of light. It also allows you to compare edges that should have a similar gradient, but if they don't, it's going to allow you to see that. Alright, the PCA, or Principal Component Analysis tool, provides a different angle to view the image data, which may allow you to notice manipulations too. As you can see, there's a good breakdown here on the help file, and also additional information in some blog posts and other links that the programmer has provided. Finally, you've got some tools like metadata, geotags, and thumbnail and JPEG analysis, which are pretty self-explanatory, but more information is there on the website. The JPEG analysis provides a lot of the same info like JPEG Snoop does. Okay, just a quick demonstration here of some of the uses of these tools before we wrap up this intro video. I'm pulling in another one of my moonshots, which is a raw image taken with my Nikon P900 a few months ago during a full moon. One quick note, the image that loads when you first point your web browser to this site is a fun little UFO image that the programmer made, so you can immediately start playing with the tools and start seeing the anomalies and manipulations to the photo that he provided. Okay, so the moon image I pulled in has not been manipulated in any other way, other than being copied from my camera to the computer. You can see the magnifier allows you to turn on or off the contrast, which can make the little pixel boxes stand out more if you want. So with the clone detection tool, you can see it finds a few potential clone parts of the image, but only a few, and as I raise up the parameters, they get fewer and farther between. Here you can see the clone stamp tool was detecting a circular edge on both sides of the image. The error level analysis is looking for potential image manipulation, and I start up with high quality and work my way down looking for changes as the quality is lowered. Next is the noise analysis, which you can see there's tons of it, which is what you would expect of a photo, or a photo that's taken, a real photo, especially at the night sky. Lots of noise. It means this is a real image. Level sweep. I'm using the sliders here to adjust the tool and looking for any anomalies or evidence of manipulation. I'm not finding much. Again, this is a raw image that has not been manipulated. Okay, the luminance gradient is a fun tool because you can see how it brings out the edges. Remember, this is a tool to begin to see how the object is lit up based on light sources, based on a light source or light sources. A ton more on this tool later, as we use it often with the photos we get from NASA and the other space agencies. The PCA, or Principal Component Analysis, is next, and you can see some of the parameters you can use to change the image and look for manipulations of evidence or editing. Finally, the metadata info shows my camera information and the date and time the picture was taken, a ton of other info that is embedded in the image when it was created. JPEG analysis shows you the quality of the image, etc. That's pretty much it for today. So again, lots more to come with these tools. You'll be seeing them often. This has been Paul on the Plane and Archer Sage. Thanks for watching. Hi, this is Paul on the Plane, and this is episode 1 of our image forensics series. Today we will walk through part 1 of our analysis of the LRO, the Lunar Reconnaissance Orbiter. The LRO was launched in 2009 with a reported project price tag of $500 million. It was originally scheduled to be a one-year mission with the potential to extend for a few more years. But we are told the LRO continues to orbit our moon now 8 years later, as NASA keeps extending its mission to study the moon and the Earth. NASA tells us the LRO experiences 12 Earth rises every day. But since it's focused mainly on the lunar surface, sending us pictures like these, there are only a few shots of the Earth we've been given from the LRO. It's these few Earth pictures we've received that we're going to analyze today using the tools we walked through in our Image Forensics series intro video. So, let's begin. Okay, we will start by downloading some of the Earthrise images from the NASA website here, Visible Earth Reimagined, the Earthrise Reimagined. So you can see this is the LRO pictures. There's 3 we're going to download here. The first one is a JPEG, compressed JPEG, it looks like, image of the Earth from the camera just coming over the moon there. The Earth is rising, so I'm just going to create a folder here on my desktop and download these 3 images. The second one is kind of looks like a full-size JPEG, so it's much larger. It takes a little bit longer to do an analysis on this one, but we're going to download that one as well. And then the third image we're going to download is a combination. So there's kind of a left camera and a right camera that the LRO has, and then those were combined. And the third picture there has been reprocessed, or some special processing has been done. But I want you to notice, first of all, as we look at these images, is that they have. We'll do the three images first. As you can see in in all of these, there's this hill or mountain in the background here at the edge of the horizon. First thing we're going to do is adjust the gamma brightness. Immediately you're going to see the 3 boxes show up for all of these images. This is indication of copy and paste, not something from JPEG compression at all. This appears that they're just pasting these images and doing a little bit of trickery there. When we bring in the large JPEG image and do the same thing, you can still see the mountain or hill there, and we do the adjust the gamma brightness, and we can see kind of close up there this box around the Earth and some other copy and paste potential editing manipulations here of the photo. So if we pull in the third image here, which is the JPEG that's been compressed, and we lighten it up, you can see now that, first of all, that hill is totally removed on the left side, which is interesting. Wonder why they would do that. And then secondly, you can see the JPEG compression there, the little colored dots around it. But look at the healing tool, evidence of a healing tool brush used here to start removing, try to remove that box, but they didn't even finish the job, which is very interesting. More on these images later in the series, and more on the boxes that are showing up around these images. These will make sense later when we go to and talk a little bit about what the box is and why it's there. The next thing we're going to do is we're going to be using Photoscape again to use a adjustment for the backlighting, and we can also do this instead of just using the gamma controls. We can just continue to lighten up the background, and what we're looking for here is anybody that's done any photography at any length will know that as you lighten up a picture, lighten up especially the background or any dark areas of it, you should see noise, what's called noise. It's something that photographers have to worry about all the time. So what we're looking here is for evidence that as we lighten up the photo, that the space or the blackness of this photo, the background, should also lighten up, and we should see noise appearing. So what we're doing here is we're using the backlight function of photoscape to brighten up the image to see if we can get any indications of noise. NASA tells us that the cameras on the LRO have noise reduction technology, which they try to explain away this, the fact that there's no noise in the photos. However, the argument doesn't hold any water for the simple fact that we should see noise reduction over the moon surface and over pictures of the Earth at the same time, but we don't. It lights up just like a normal photo does, and doesn't at the same rate that it would, or that space or the blackness would. Also want to point out, as we lighten these images up, notice how the shadows also stay completely black. Those also should lighten up as you adjust the levels of the photo. And we'll demonstrate that by pulling in some real raw images, ones that I've personally taken with my own camera or cameras, and you can see what that would look like if the photo is real. This is what we should experience. So I'm going to start by pulling in some shot here of the moon that I took with my P900, and as you can see, as I start to brighten this up, look what happens to the blackness around the photo. You can go in there and adjust the backlighting, the gamma brightness again. I'm looking for evidence of the noise, and as you can see, there is a ton of it, which is quite different than what we saw from the LRO images that we received. Here's another way to do it, is to pull in a picture with shadows. So this is just a picture I took from when I was at Lake Tahoe. There's a cool restaurant up at the top of the lifts, one of the lifts, and as you can see, the shadows there that were black in the picture are completely being illuminated by these tools. And this is what we would expect to see in a real photo. Look at the shadows there and how dark they are, and what we're looking for is noise when we brighten up the photo. You can also use, like in Photoshop, luminance curves, and you're able to adjust it, the colors and the luminance, to see if we can find any noise or any other potential photo manipulations. And as you can see, this is all reacting how we would anticipate it to react when a tool like this is used of a real raw image. Pull the same photo or do the same analysis in Photoscape, and where's the noise? Where does the noise appear in the photo? As you can see, these are just images pasted on a black background. Okay, for this next forensic analysis, we're going to drop the 3 JPEG images from the LRO that we received into JPEG Snoop. And this is going to, again, works with JPEGs only. It's going to analyze and tell us, does this look like this photo's been edited and manipulated? And we can see in all cases here that the program is indicating that this is a class 1 finding, and it's been processed by Photoshop, been edited by Photoshop. We'll drop the second one in there. So it takes a little bit longer. It's a little bit larger photo. But again, JPEG Snoop, with its database of signatures, recognizes that the image has been processed, it's been edited, and Photoshop signature is found. These are directly off the NASA website. These are supposedly real pictures, but boxes around them, not seeing any noise, and now seeing evidence that they've been photoshopped. Okay, for the final portion of our analysis today on these LRO Earthrise images, we're going to use one of my favorite tools here, and that's the Forensically program. So we're going to start by pulling in, again, one of my moon shots. So we want to use this tool on an image that I know is raw and unedited and a real picture, not something created in a computer program. And as you can see, using the magnifier, what I'm looking for is, again, looking for noise, looking to see if we can see any indication of noise, which is, if you take a real picture, anything that's black, as you brighten it, you're going to see noise. And so we're going to use the noise analysis function here, and wait and see if it comes back with any noise. And as you can see, it's completely covered. So obviously, anybody that, again, done any photography, knows anything about photography, you're worried about noise as you illuminate the image, and with any illumination, you can see the noise is popping up, and it's covering the photo. We can try this with another photo. Again, I've got some other pictures here that I've taken personally. One that I would like to use is taken from the Space Needle at night, and as you can see, a ton of black sky here. No stars showing because obviously I'm focused on the city and all the lights. We do our noise analysis. Let's look at what the sky does and any other shadowing parts of the image, and let's see what the noise analysis comes back with. And as you can see, completely full of noise, all the shadows, all the black sky, anything that was dark. When you do the noise analysis, you're coming up with a lot of noise, as you would expect. So now if we go in and pull in some of our downloaded LRO images, we do our noise analysis. Where is the noise? This is obviously an image pasted onto a black background. That's not space. Look at the shadows as well. Don't even lighten up. NASA, in their publications, in their commentary, say that there are noise reduction filters on their cameras, which may be an argument that why no noise would show up, but if that were the case, we should not see the noise as much as we do see over the Earth and over the Moon in these images. Just another quick reminder that all of these tools are available free, and you can download them and use them today. We'll include the links for all of the tools in the video description. We'll also include the links for all of these photos so that you can download them, pull them into these tools, and do the same exact analysis yourself. Alright, so let's recap what we've covered so far. We've got boxes around the images of the Earth, attempts to remove the boxes around the Earth. We've got mountains or hills removed from some images, but not others. We've got Photoshop being detected. We've got very strong indication the images of the Earth and Moon are pasted onto a black background because there's no noise in the black areas and what appears to be fake shadows on the surface of the Moon. Maybe we're starting to see what our $50 million a day is going for. So this is going to do it for part 1 of our series on the Lunar Reconnaissance Orbiter. Again, the boxes around the images of the Earth will come into play later in the series. You haven't seen the last of those by a long shot. We hope you have enjoyed episode 1 of our Image Forensics series. On behalf of Archer Sage, this is Paul on the Plane. Thanks for watching. Hi, this is Paul on the Plane, and this is part 2 of our analysis on images from the LRO, the Lunar Reconnaissance Orbiter. If you recall from part 1, the LRO was launched in 2009, and we are told it is orbiting the Moon, taking pictures of the lunar surface, but occasionally does send us a picture of Earth. Here in part 2, we'll continue examining and scrutinizing LRO Earth images, and then in part 3, we will focus on the images the LRO is providing us of the lunar surface itself. We'll begin by navigating again over to the Visible Earth website on the NASA domain. Here's a handful of images entitled Earth from the Moon. The link is in the video description. These images also exist on the LRO website gallery of images, unlike the vertical Earthrise image on the Earth Reimagined page with its missing mountain or hill that we analyzed in part 1 of the LRO series. At the bottom of the page here is 3 images that I've downloaded, and these are the ones we'll be focusing on here in part 2. So we're going to drop them all into Photoscape as a first step, and the first image here, as you can see, has had text added, so we know it's been edited with a transparent text file. This image also does not have a box around it, like the ones we saw in part 1. But you can see the little dots, little colored dots around it, which is JPEG compression, meaning, in a forensic analysis of the edge here, it's revealing that it's been pasted onto a background. Okay, the second image here is the so-called original. It has no text on it, but it does have a box around it. What's interesting is that the box shows the Earth image has been very tightly cropped, as you can see when you adjust the gamma brightness. If this was the whole image originally, why is the camera capturing this image with the Earth right on the edge of the frame? And then why would NASA put it on a black background that is just a little bit larger? Okay, the third image here is the really interesting part. It's labeled as a reference map, and as you can see by the file name, NASA admits this is an infamous blue marble image. Good old Rob Simon is credited in the article too, and I'm sure you remember his description of how the blue marble was made, from the MODIS system on the Terra satellite strip data in 2004, right? Here's a brief clip with Rob explaining how it was manufactured.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it's a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
Also, you can see the reference map blue marble image is the same exact dimensions as the second image from the LRO, 4,000 by 4,000. Again, the second image we are told is a real one, and NASA emphasizes it here on this page, that it was captured by LRO's two narrow-angle cameras, one on the left and one on the right. You'd think that would mean we'd see two halves of the picture, and maybe by analyzing it we'd have a line appear down the middle of it, or something like that, but we don't. Just a box over the whole image of the Earth pasted onto a black background, it appears. Okay, so back to the reference map. I'm going to pull it into Photoscape here and click Object, click Photo, and the reference map I'm going to put right on top of the LRO image. And you can see when I start sliding the opacity slider here. Are you seeing what I'm seeing? Look how they fit exactly perfectly together. Are you seeing this? NASA has just taken a blue marble composite image that Rob Simon made in 2004 and simply added clouds and made it black and white. We find it really hard to believe they would even release this image and claim it was taken by the LRO from the moon. How can the image from the LRO be real if the images used to build the blue marble are real? What are the odds that this one image they snapped when they say they were calibrating the LRO's cameras in 2010 flying over the moon is an exact match, in fact a mirror image, of the blue marble Rob Simon compiled? Now some may argue this could be explained because of the differences in cameras' focal length and point out that continents may appear to change size, like this image here that we were given, where North America looks really big. Never mind that the whole United States is a desert, and Texas seems to go all the way across. Well, they say everything in Texas is bigger. But the blue marble, we are told, was taken from strip data by the Terra satellite from 438 miles away from the Earth, and they had to combine all of the data it captured over many months from each orbit to piece together the blue marble image. But it's exactly the same picture the LRO snaps from 239,000 miles away, the same exact image size, and the edge of the Earth is the same distance to the edge of the image in both photos, and all from the same exact angle? There's no explanation for this other than the obvious. They added clouds to the blue marble, made it black and white, and just tell us it was snapped from 239,000 miles away. Okay, so if we go back to the NASA website here and click this blue box at the top right, you will get the same story about the LRO Earth from the Moon image, and you can see the dates that NASA acquired this image, 2010, June, and the date they acquired the reference map, June 2004. So almost exactly 6 years apart from 230-something thousand miles difference, and they fit perfectly together. Okay, now let's head over to the LRO image gallery, which sits on the Arizona State University domain. The link is in the video description. Here you can find the alleged raw images from the LRO, or real images, if you will. Search for Earth here in the search box, and you can find this same image, Earth from the Moon, that we've been examining. So here it is, June 12th, 2010, but this is a PNG file. It was a JPEG on the NASA site. You can also see the box at the lower right with the text in it. And if you remember what the JPEG looked like, with the same part of the image missing, but NASA said it was cut off because the prediction of the exact time when the camera's field of view would cross the Earth was off by a few seconds. Alright, we'll put the PNG file we downloaded from the LRO image gallery now into Forensically, and use the string extraction tool, and guess what we see? Evidence of Photoshop signature. So much for a raw or unedited image. You know, if there was a court battle and these pictures were submitted as evidence, forensic scientists would, be scrutinizing these images, and they'd find the boxes around them and see evidence it was in Photoshop by the signature, and look for noise and look at the edges and the illumination, and these just wouldn't fly in court, in a court of law. They wouldn't even be accepted as evidence. They would be debunked immediately and thrown out. But so many of these images in the LRO image gallery don't have any noise. So many that it creates a strong, reasonable doubt about the validity of the claims these are real images. Okay, for the final point we will make here in part 2 of our analysis of the Earth images we are told are captured by the LRO, allegedly, we are going to focus on the subject of ambient light. Ambient light means light that is already present before any additional light is added. It's natural light, so to speak. To provide an example, I'm going to drop one of my moon images I took personally with my P900 into Forensically, and by using the level sweep slider, you can see this halo appears around it, and that's its ambient light coming off of the object. Now, whether you believe the ambient light is created by the moon or is a reflection of sunlight, that's not something we're going to debate here. The point is the light is coming from the moon, and as you get further away from the light source, as you can see here, it just gets darker and darker. Alright, now let's pull the PNG file of the Earth from the LRO gallery and do the same analysis and look for ambient light. We should see all kinds of ambient light emanating from the Earth, with 70% of the Earth being water? Think of the amount of light reflection we should get as opposed to the moon. All the water and the air reflecting sunlight, but no ambient light in this image whatsoever. It should have an even bigger and more prominent glow around it than the moon. So even with no box around it, that tells us this was still a copy and a paste job onto a black background. And then the string extraction tells us it was indeed photoshopped. Yep, so here we have another fake image. Did you know that NASA has released pictures of the sun and it has no ambient light around it too? Are you serious? Check it out for yourself. Okay, that's a wrap on part 2 of our LRO image analysis. Let's quickly recap. This set of LRO Earth images from the moon were created originally, it looks like, as a PNG file in 2010, with the Earth pasted over a black background with a box around it. It then has its box removed and is saved as a JPEG. The reference map they included is a blue marble image comprised of strip data taken from 438 miles above the Earth 6 years earlier in 2004, but it matches exactly with the alleged real image taken by the LRO 239,000 miles away. Secondly, real images contain noise, and if there is light emanating from it, they will also have ambient light, which can be found by adjusting the levels in photo editing software programs. However, none of the Earthrise or the Earth from the Moon images from the LRO have noise or ambient light, because they aren't real. We hope you can see the inconsistencies, the anomalies, the irregularities we are being fed by NASA and these alleged real images of Earth. Why is NASA releasing fake pictures of our world and tell us that they are, can be used in museums and textbooks and used by teachers and scientists? If the images have been manipulated in any way, then what scientific value do they even hold? Isn't science about the search for truth? On behalf of Archer Sage, this has been Paul on the Plane. Thanks for watching. Hi, this is Paul on the Plane, and this is part 3 of our analysis on images from the LRO, the Lunar Reconnaissance Orbiter. If you recall from parts 1 and 2 of our image analysis series, Faking Space, the LRO was launched in 2009, and we are told it's orbiting the moon, taking pictures of the lunar surface, and occasionally sends us a picture of the Earth. We analyzed the handful of Earth images the LRO sent us in parts 1 and 2 of this series, so in part 3 we're going to spend our time examining images the LRO has sent us of the lunar surface itself. Before we dive in, however, let's review what real images look like using Forensically, the free web-based tool online that you can pull any image into and use various functions to analyze and look for evidence of manipulation and editing. The link for Forensically can be found in the video description. Okay, so to begin, I'm going to pull in some more moonshots that I took with my P900. I really like this first shot. I'm going to analyze. You can see the clouds in front and behind the moon, which is interesting. So what we're going to focus on today is the noise. And as you can see, when I click on the noise analysis function here of Forensically, you see very consistent pattern of noise over the entire image, really. The trees that kind of frame the shot, the moon itself, and then obviously the large area of sky shows nothing but large areas of noise in a very consistent pattern. You could also sometimes use the error level analysis tool like I'm doing here to just see if there's any anomalies, looking for something that might have been pasted into the image or something like that. And as you can see, the colors here are pretty consistent, and as I crank the JPEG quality down, I'm looking for evidence of manipulation of the image, looking for anything that might appear to be out of the ordinary, and not finding anything. And that's because this is a raw image straight from my camera, the Coolpix P900, and I just dragged it right onto my computer. Alright, the next image is a full moon shot that I took sometime later, and we're going to start by doing a noise analysis, which in Forensically is really just a few clicks of the mouse. You pull the photo in, go right to the noise analysis. This image was quite large, so it takes a few minutes for a few seconds for it to load up. And as you can see, when I apply the noise function and slide the opacity slider up there, you can see a very consistent pattern around the object and over the object of noise. And then again, going to the error level analysis tool, looking for evidence of any copy and pasting. Does this look like that this was pasted over a black background with all the noise? Wouldn't appear so. And then as I crank down the JPEG quality, actually you start to see the cool ambient light that the moon is giving off here. Some very consistent patterns around it, what we'd expect to see from a real raw image. Alright? Okay, from here let's dive into images that I downloaded directly from the LRO gallery. Link will be in the description. Picked out some very interesting photos here. There's tons of photos on there, but I picked out the ones that I thought were the most interesting, and we're going to pull these in one by one, and we're going to do our noise analysis, and in a few of them I'm going to do my ELA analysis, and I'm looking for what you just saw. I'm looking for noise. This photo here, as you can see, an interesting shadow, kind of a cone-shaped shadow, but when I pull the or apply the noise function, where's the noise in the shadows? And that's the problem with these lunar images. I'm going to just start right off the bat by stating these shadows appear to be completely just added after the fact. They don't appear to be natural whatsoever. They are simply modifications to the image itself. And as you can see, when we are pulling these images into forensically, when we are applying the noise function, the ELA, error level analysis, we do not see consistent noise patterns. We're seeing evidence of manipulation to the image, things added, and that's what we find in tons of these photos in the LRO gallery. Here I even go into the luminance gradient and looking at the interesting patterns, and not seeing any texture whatsoever in some of these parts of the photo. Let's pull in the third one here, and these get very interesting. As you can tell, you see some shadows there, and just look at the edge of the shadow there. You see how it's not very sharp. To see, it almost looks like it's a kind of a fuzzy shadow there. That would tell me that the object that is casting, or the surface there that's casting that shadow, would also have that same effect. It's not sharp at all, which is interesting. Then when I slide the opacity slider up, you can see some noise. You can see lines of noise, but what are these boxes? What is that box there, and why isn't the noise consistent throughout the entire shadow? This is clear evidence of photos that are manipulated, things that are being added after the fact. We don't see any consistency at all. You see a number of anomalies, irregularities in the photos. What's that perfect rectangle doing in the bottom of that photo? If we go to the ELA, you can see the colors even provide a little bit more of a contrast to see the irregularities in this photo, in these shadows that are clearly added after the fact. Does that look like the real images that we analyzed at the beginning of this video? As you can see, very, very different. All right, we'll go to the fourth one. Here's a couple of what it looks like islands in a sea, but these are supposed to be obviously peaks that are not not in the shadow. You can see some noise in there. As you can see in the magnifier, you can see that some noise is showing up. So as we lighten up this photo and bring the noise to the surface, you can see parts with some consistent noise, and then it slides into parts that don't. And as you recall from those other photos that we did and analyzed, a very consistent noise pattern, but these photos of the LRO, nothing of the sort. Very, very weird stuff going on here. All right, moving on. All right, this is a very interesting one because of the fact of this shadow has a kind of a different edge to it. The very, very left of the shadow is pretty sharp, and then it gets into kind of a blurry edge to the shadow. And you can see the other shadows there not showing any noise. When I increase the opacity slider up, looking for noise and not seeing any. Completely black. These are obviously added to the photo and not occurring naturally. We do the ELA, and what is going on with this shadow? We've got a shadow in a shadow. Got some very, very weird stuff going on here. Very inconsistent with what we would expect to see of a real photo. And as you can see, as we use the ELA analysis, we can really put a contrast in the different areas that had been shaded. My guess is that they started with a smaller shadow and then decided to expand it, and we've got some layering going on, and I think that's what the ELA is showing us. Alright, moving on to the next photo. This also shows kind of a sharp edge to the shadow, and then it gets a little bit softer, a little bit blurrier, not consistent at all with what we would expect to see in real life. And you can see a little bit of noise in there, again, using the magnifier. What we're going to be looking for, again, is consistency in the noise. So as I crank the opacity up to see where the noise is, you can see a little bit of inconsistent noise, but not really a pattern to it at all. Some parts with and some part not. Sometimes, again, we have to use the ELA to lighten up parts of the shadows, using be able to use a contrast of different colors. And so as we crank down the JPEG quality, raise up the error scale, we can start to see the differences in the image, and some really, really weird stuff going on here. This is clear evidence of photo manipulation, editing of the photo, and then being told that this is real, and it's nothing of the sort. Alright, the next one we're going to pull up is this one here. Again, we're just looking at these shadows, looking for noise, looking for any inconsistencies. You can see by the number of these photos, there's, as I mentioned in part 2, enough photos here with these anomalies, lack of noise, inconsistent noise. You know, what's this? You've got noise just kind of in the middle of it, but the outline of the shadow doesn't have any noise. Very, very weird stuff here. Enough photos in the gallery here. As you go through them, what you're gonna find is enough to, bring enough reasonable doubt for any, reasonable person that's looking at these, that they're full of inconsistencies and anomalies and don't appear to be real whatsoever. So here's an image that is throwing a big shadow, a peak, with a large shadow. So let's do our noise analysis here. Don't see any noise with the magnifier. Looks just like black pieces that have been pasting over it. But when we raise the opacity slider up, we can see that there is some noise. Now, it's not consistent, as we would expect to see, but you can see that there is noise. However, you can see that the edges of the shadows don't have any noise. So, a for effort there, NASA, trying to add noise. Looks like you missed the edges of the shadow. Next time, you're going to have to try a little harder. Alright, just a few photos left, and we will wrap up for today. Let's pull this one in real quickly, just looking at a couple more shadows of some areas that are hidden from the sunlight. Again, as we would expect, seeing a pattern here of no pattern of noise. This one here that I'm pulling up now reminds me of Yoda. Looks like Yoda with some ears there. This whole photo is mostly a shadow, but as we do our noise analysis, as you can see, no noise showing up in the dark areas. Completely fake photo here. Fake shadows. Not what we would expect to see in the slightest. We do a little bit of an ELA analysis now, and look at this consistent color, the gray, then the purple and the green for that huge area. That just tells us that's just basically black paint that's been added to the photo. Alright, the last one we're going to look at here from the LRO image gallery. Looks like an island here surrounded by nothing but shadows. Obviously a very higher peak, and our noise analysis shows, again, nothing but blackness, no noise around. the image. In fact, as we do the ELA analysis, we see very straight edge there, and this coloring around the image shows clear manipulation, and an edge that was added later as the shadow was added. These pictures are completely fake, but they're on the NASA website, or excuse me, they're on the LRO image gallery, and we're told that these are real images from the LRO that have been sent to us by a camera that's been sailing around the moon for like 8 years or something like that. You be the judge. Alright, before we wrap up, I've got a little treat for you. Here is a image that I wanted to share with you. It's an image of the Earth, and as you can see, just floating there in space. And I want to show you that I did find one that has some noise in space. So I wanted to show that to you, and I'm going to slide the opacity slider up, and as you can see, a very consistent noise profile. So maybe this is a real image. Maybe this is one that we could say, you know, we can't really debunk because of the fact that it's completely full of noise. Maybe this is a real image. When you go over to the ELA and we start cranking down the JPEG quality, we can see, you know, what we would maybe expect to see. Again, look back at those earlier images that we analyzed. But I've got a little confession to make. What I simply did was I went into Photoscape and I created a image with a black background, and I just went to the filter and I went to the noise function, and I just added noise. Added some noise, and then I pasted Earth, pasted a picture of the Earth right on it, and I saved it, and I pulled it into forensically, and I did a noise analysis, and you saw what happened. Nothing but noise shows up. So this stuff's easy to fake. I'm wondering why the pictures that we get from the LRO and these cameras don't have any noise. Food for thought. Okay, that's a wrap on our 3-part Faking Space series of the LRO and the Earth and Moon images the Lunar Reconnaissance Orbiter has been sending us over the last 7 or 8 years. Let's do a quick recap on the LRO series as a whole. The images of the Earth we have been provided by NASA have been seen to have boxes around them or show evidence of JPEG compression, meaning they've been pasted onto a black background. We've seen mountains or hills removed. We're told that the image the LRO captured of the Earth in 2010 from 239,000 miles away is a exact mirror image of a composite picture pieced together by stripped data in 2004 from a mere 438 miles away from the Earth. We find no noise in the shadows and dark areas of the image of the Earth or the moon surface itself, meaning they aren't real, and we don't see any evidence of ambient light, which we most certainly should if the pictures are in fact genuine. In our next series of Faking Space videos, we will be analyzing images we've been given from the Discover satellite, the Deep Space Climate Observatory, and its EPIC camera, which we are told is taking amazing pictures of the Earth from 1 million miles away. Remember those boxes that appeared around the Earth LRO images? Well, we haven't seen the last of those by a long shot. So stay tuned. We've got a ton more in store. On behalf of Archer Sage, this has been Paul on the Plane. Thanks for watching.